So for the last 5 years, we at West Yost have been working primarily in the water sector to bring cyber-informed engineering to as many water and wastewater utilities as we can. And through that process, we've had a couple of missteps. We've had tons of lessons learned. We've got tips and tricks. We've got some communication strategies, terms, and of course, bunches of case studies. So my goal here today is to share those with you so that you can take those to your organization, to your teams, and use them to implement CIE. So we always want to start with the end in mind. So the National Cyber-Informed Engineering Strategy states that when CIE is fully implemented, engineers, so we're talking about the civils and the mechanicals and the electricals, all of the different types of engineers in the family, we all incorporate cyber into our body of knowledge, including engineering minimum requirements and specifications, and that's real important for one of our case studies later on, for the physical infrastructure systems that incorporate digital controls. Now, what's happened over time? Over the last 4 or 5 decades, of course, we moved from being very analog to now having digital technologies integrated completely within all of our physical infrastructure. And I'll say all with a little asterisk because I have heard that there are a couple of water utilities in Indiana specifically that don't actually have any automation, right? They're just doing very, very simple things. Now, the engineering, right, we like to think that engineers can be kind of slow to evolve, and that's absolutely the case. But at the same time, we've made some really big advancements in the last, let's call it 120 years. First, once earthquakes became something that we were very concerned about after the 1906 San Francisco earthquake, the Uniform Building Code was updated, the International Building Code was updated, and now we do things very differently. I personally have been through 2 earthquakes, and the building I was in did not collapse. So we won both of those. The second time is in health and safety, right? And when we think about health and safety, one of my grandfathers actually was missing a finger because it got caught in the flywheel. And that was probably in about 1955. Back in the 80s, right, we started to realize that health and safety was something we really needed to engineer for, and we made really significant leaps and bounds, thankfully. Now, a little bit of background on CIE, just to really set the stage. Right? We're talking about using engineering design decisions and controls to eliminate those cyber risks. We want to engineer out those cyber risks, and CIE really gives us an excellent way to do that. For most of the life of the cybersecurity practice, we were very focused on IT and then OT, and finally, those people that we work with from those disciplines are delighted that the engineers and operators are now part of the conversation. So of course, we focused on functionality, safety, reliability, and now we want to extend to cyber resilience using cyber-informed engineering. There are 12 CIE principles. You can see 6 here. I have used a grouping called design and operations, and there's a second grouping called organizational. These are not official groupings, but what I have found is that when we group these like this, it is easier for the asset owners to understand what cyber-informed engineering is and how to go and do it. Now, the principles and the key questions here, you've probably read most of them already. Those come from the Cyber-Informed Engineering Implementation Guide, and we will come back to that a little bit later in the presentation. So I want to focus on a couple of these, some of the things that make CIE really unique. So consequence-focused design. We like to start here. While we do like to think that all 12 CIE principles are equal, consequence-focused design is kind of the greatest among the equals. This is where you really say, hey, how are we going to engineer this system? What are we engineering out from a cyber risk perspective? What do we absolutely have to be able to do? And we have seen many, many utilities really take this seriously and do wonderful things. Engineered controls, right? Ginger, right, from INL likes to say that you can't do CIE without going through the engineered controls warehouse, and we 100% agree with her. Now, one story that actually is about 7 or 8 years old now and really predates our efforts with cyber-informed engineering is I was out at a water treatment plant, and hopefully some of you have been at water treatment plants so you can kind of see this. And I go to the pipe that's bringing water into the plant. And this is about, about yay big. Water's cranking through it all the time. And so I look at this pipe, it's a brand new steel pipeline, really, really nice. Everything's in great condition, except I look at one of the supports, and the pipe is not centered on the support anymore. And there's this little rust line there. And so I turn to the operator who I was with and I say, hey, so what happened here? This doesn't look right. And he goes, oh yeah, this automated valve here, the actuator closed it a little too fast. And there was something called water hammer, right? And there was enough energy in that the pipeline went up and back down and moved over 6 inches. Now, luckily, that pipeline was brand new. But I would also venture to say that pipeline cannot handle too many of those events, and it shouldn't, because it reduces the life of the assets. And we see that all over the sector. So, I turned to them and I said, well, did you just re-gear the valve? And they go, oh, no, but that's a really good idea. We just changed the program in the PLC. And I went, okay, all right. Well, now, I'm doing an assessment. I have a recommendation. You'll see that later. But that was one really excellent sort of engineered control in that changing the gearing on the valve. So there's no way an attacker could make that valve close too fast or too slow again. I'm going to skip down to active defense next, because this to me is one of the best sort of blending of the old with the new and the best of each world. So I was at a conference much like this, and I was talking to a wastewater operator who had begun his career in the 1980s. And his mentor used to do his rounds every day. And when he would do his rounds, he would go by the wastewater sludge beds, he would get a little scoop in his hands, he'd feel it, make sure the texture was right, and he'd give it a sniff, right? That operator was so in tune with his process that he could do those things and get a pretty good feeling of how healthy that process is. And I say healthy because, right, those are bugs in there. Now, you take that level of awareness, and many of the operators we work with are really, really, truly experts in their facilities. And they know how those things, they sound, they feel, the vibrations, how they smell. And you layer over newfangled capabilities like network monitoring, right? And then, so you take the operators and their knowledge, you take really well-tuned active monitoring, and then you say, hey, what are we gonna do when we actually see something? And you lean into incident response. So that's one of my favorites because it's most actionable and it's really easy to build through tabletop exercises. Now I'm going to skip up to secure information architecture for a minute. And this is not necessarily something that's very unique to cyber-informed engineering, but one of the things that INL does is they lead a community of practice for CIE practitioners. And we have regular phone calls, and after one of these phone calls, I call my buddy Tom, who was on the call with me. And I say, hey, Tom, I know you're a network guy, but what do you think of this consequence-focused design and engineered controls concept? And he goes, Andrew, I don't think about it a lot because I'm a network guy and I'm so focused on the secure information architecture and layered defenses that I need to leave the engineering to the engineers. And that was a real aha moment for me, because what it demonstrated is that cyber-informed engineering has so many different entry points for so many different people that if you're a network person or a process engineer or an operator, you can pick this up and there's something for you, and you can move forward with the rest of it after that. So that's the first 6 principles. The next 6 here, we call these organizational. And what I want to focus on, there's 2 elements here, 2 principles. First is planned resilience. So for anybody who's done incident response, anybody who's done emergency preparedness, if you look at that key question, how to turn what ifs into even ifs, have you ever heard such a wonderful capture of the concepts of planned resilience or emergency preparedness? I mean, I don't know who to actually attribute this to. It's definitely not me, but it is fantastic. The next one here is engineering information control. So in the water wastewater sector, we are primarily public organizations, which means we have 2 burdens. One is that our procurement documents overwhelmingly have to be publicly available. The other is that we are taking taxpayer money and we're doing really great things with it. And so we both have to tell the public what we're buying, and we have to show them that we're doing really good things with that money. So it winds up in public tours and all of that sort of thing. Now, we've seen some real improvements on this in the last 5 to 10 years, whereas a client would have to explicitly say what PLC model and what network switches that they wanted to procure. Now they can actually go and say, hey, we'll tell you about it later after you're selected, which is a much better way to do it. And their procurement staff are starting to understand the risks of leaking this information. Now, I say that, but during one of our recent CIE projects, I was poking around on the client's website, and I actually found the engineering specifications for their PLCs and for their network gear. This was all publicly available. And then, because just like probably many of you, I'm trying to understand what AI and large language models are actually doing for us. So I turned to Perplexity, which is my LLM of choice, and I say, hey, Perplexity, why don't you tell me what type of PLC this utility uses? And the wheel spun for a minute, and it, of course, popped out the exact right make and model. And I was really alarmed that anybody could go and start asking these questions. Luckily, I did it for a couple of my other clients, and it couldn't tell me anything. It would say things like, oh, mostly the water sector uses Rockwell. Okay, good, excellent, Perplexity. That's about what I want you to tell me. So we, as a sector, really struggle with this. It's something we're getting better at, and we're trying to keep that information out of the wrong hands. Now, let's talk a little bit about kind of the skills and the who's who on the CIE team. And there's a lot of normal roles here, right? The project manager, et cetera. We're not going to get into that. But what I do want to start with is a really important concept. Now, I represent a team of engineers and OT cyber specialists, and all of us are civilians. So this concept, for those of you who did serve in the military, is going to be kind of a no-da, which is totally fine. But through our work doing CIE work on existing infrastructure and infrastructure in design, we found that commander's intent was a really important organizational principle. Without that, we kind of couldn't get at the consequence-focused design components, and we also didn't really have a way to provide comments in a constructive way. And I'll get back to that a little bit later. And when I say constructive, I mean within the CIE worldview. So other than that, key skills here, you got to have that mission commander. You got to have all the subject matter experts. And I want to go down to that last sub-bullet. One of my clients recently told me that he goes, Andrew, the most important person here is really you have to have someone who knows how to break stuff, and they love it, right? They really enjoy it, right? That's what actually gives them that dopamine kick. So you got to find that person. Now, I like to say that I have 3 kids, because I do. 2 of them could be excellent engineers. One of them, he's that guy. He breaks everything his engineers build, his engineering brothers build. So, we have those people around us. Make sure you leverage them for that creativity. All right, so how do we begin? Now, there's going to be a couple things in here, and you're going to say, oh, yeah, that makes a lot of sense, right? So you want to have leadership. You want them to be aware of the threat landscape in the water sector. Unfortunately, we've had some pretty high-profile incidents lately. And because of that, there's been a huge amount of awareness building. OT is kind of outgrowing IT's protective cocoon, and engineering is really starting to engage, but maybe they don't really know how yet. So I was running a workshop, and this electrical engineer, probably about 30 years of experience, he's sitting in the front row, and he's kind of grumpy because, of course, he has real work to do. Why is he sitting there with me? And after about the first half hour, he gets this big grin on his face, and I go over and I talk to him. And I say, hey, why are you smiling like that? And he said, you know what? I've been trying to explain this problem to my leadership for years, but I just never had the words to do it. CIE is that argument. It gives people the words to really discuss this and how to address the issues. Now, there's one other thing here that's super important. And that is when we go into these organizations, and so we have done in the last 10 years, let's call it 150 cybersecurity assessments. And now we've been doing cyber-informed engineering assessments. And when you do the cybersecurity assessment, we find, especially 8 or so years ago, they were really challenging conversations because the utilities hadn't done enough yet, and they knew it. But when we're talking about cyber-informed engineering, and you're talking to the engineers who maintained engineering controls, you're talking to the operators, and you're saying, hey, can you operate your water system without any type of automation? And they say, yeah, Andrew, that was Tuesday, right? Now you've got these engineering and these operations capabilities to build cybersecurity capabilities upon. And you give these utilities and these asset owners a lot of really wonderful quick wins in this concept. So with that, that's an organization who's ready and getting down the road on CIE. Now, there are some key assumptions here, and you've seen these before. If you're in IT or if you're in OT, right, you're pretty familiar with these, and you're kind of like, yeah, we get it. But for an engineer or an operator to take these and to really internalize them, you get to a point where they become defenders of their infrastructure. So I'm just curious here, who here would consider yourselves to be defenders of your critical infrastructure? Yeah, all right, good. That's about what I would have expected. So if I asked that question about 5 years ago, I would get 2 people in the front row who would sort of slowly raise their hand, and they looked a little haggard. That's because they were in IT, and they weren't able to communicate the need of cyber-informed engineering and cybersecurity in general to the rest of their colleagues. But now when I ask that question, I get maybe about 30 to 40% of the people in the room will raise their hands. And that's really excellent, because when we're doing CIE, we want a very specific mindset, right? We want them to say, we're ready for you. Take your best shot. And when we do this, that allows the engineers and the operators to really get into the weeds. And if you're going to talk about, hey, we're going to finagle that pump in a way an attacker might, what are you going to do about it? And they come back and they say, you can't actually finagle that pump. And we say, that's great. That's a win. Right? So this is really, really important. I also just really love this meme. So with that, I have 2 case studies here. The first one is very fast and very furious. Why do I say that? Because we did this work in about a month. The second one is a little bit longer, and we'll get there. Now, we had a client who has a very important booster pump station. That booster pump station sits at the bottom of a ridge, and it pumps water up to additional pump stations and reservoirs and serves a very large residential area. Unfortunately, they had some real control system issues, and within the context of our project, we couldn't fix those. So they were spending half an FTE going out and hitting a reset button. And that seems like a lot, but it was a big urban area, and that's just, travel time, et cetera. That was the reality in which they were living. And they said, hey, we're not going to spend half an FTE on this anymore. So what they did is they came and they said, hey, West Yoast, we're going to do SCADA in the cloud with control. And there's a little bit of a physiological reaction when I say that out loud. That's totally fine. But we said, hey, clients, no thanks. We don't do SCADA in the cloud with control. And they said, we're the client. Yes, we do. You're coming along on this ride. And we said, okay, we will do that, absolutely. But we're going to do CIE on this ride. And they said, let's go. So what we did is we started with consequence-focused design, and we said, all right, if an attacker gets in, what are the worst things they can do? We created some of those worst cyber day scenarios. And then within that, we said, all right, how do we actually control those? We worked very closely with the SCADA in the cloud vendor, and of course, at the beginning of the conversation, they swore up and down that nothing could go wrong. Nobody could get into the system. But then we asked the guy who ran it, and he said, well, you're the admin, you're in the system. What if you decide to do something? And he said, oh, that's a really good point. Okay, I'm in, right? So what we wound up doing is we included a little time delay relay in the field unit from the SCADA in the cloud vendor. This makes it so that you can't cycle a pump on and off uncontrolled. Now, that's really important because the setting for this utility was that if you damage a pump, it's a really, really bad day for a lot of reasons. And this mitigation actually made its way permanently into that field unit that SCADA and the cloud vendor was selling. And so from his perspective, he had totally mitigated all of the risk associated with that scenario. So the client was very happy. They saved half an FTE. We were very happy. As engineers, we could sign off on this and be really comfortable. And the SCADA and the cloud vendor got a huge improvement to his field unit by being part of the team. Now, this is probably one of the most important terms that we have come up with. And so when people are talking about CIE, and I'm in rooms full of people with them, this concept is probably one of the most helpful things. Engineers are very familiar with the concept of a failure mode. Now, engineers necessarily, they haven't necessarily thought about if someone's on the other side of the planet, connected to them, and what that person could intentionally do. But when you bring that concept in, this is really, really helpful. And so when we think about those worst cyber days, we've actually kind of rebranded them as cyber-enabled failure modes. And that's been pretty impactful. Now, this next one, I call it building Rome because as you see when the timeline hits here, it took quite a while. It took a couple of years. This client really wanted to build CIE into their engineering culture. Now, you can see we started this back in October of 22. Because of the engineering milestones, we actually came into the design of a water treatment plant at 60% and at 90%. And when we did the 60% review, which doesn't include a lot of electrical, mechanical, or control system drawings or specifications, we had relatively few comments. That should be, expected at this point. But at 90%, we had a lot of comments. And what we found ourselves doing is we were just being engineers, reviewing an engineering drawing set and specifications. And within that, we came up with a bunch of comments, but they were kind of unconsolidated. So this is where that idea of commander's intent becomes really, really important. So I was swimming in all these comments and I said, all right, team, we need to organize these in a specific way. Here's the process flow diagram. I think you can break this place here, 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 and here. You're gonna tell me we can or we can't. Organize your comments accordingly. And that became almost instantaneously the best way that we had figured out to communicate with the client around the value of CIE and the mitigations that we propose that they implement. Recently, we handed over the draft design guidelines, and those are currently in review. You can see the table of contents here. Number 6 is the one I really want to highlight. So this utility is a big water wastewater utility. They're going to come up with their preferences around CIE. And this is the section where we started. We dropped a couple of bullet points in here. But what's going to happen is as they design and implement pump stations, lift stations, water treatment plants, et cetera, over the next 5 to 10 years, this is going to grow. And these are the things that we really need to have happen and communicate about within our sector to really just make ourselves more resilient in general. So this is a meme that I made. I'm very pleased with it. Thank you. My goal here is really to redefine how we as engineers do business, right? We have successfully done that when it comes to seismic resilience. We've done it with health and safety. And there are utilities out there who are really embracing CIE. So I recently had a client, and this is within the last few weeks, tell me, hey, we have to build a new water treatment plant. We're gonna replace our old one. Our old one, we can't run it without automation. Anything we build, we're gonna be able to run that in manual. And so if you think about this, the cyber-informed engineering conversations are shaping a 9-figure investment that'll land around 2035. We have long planning cycles. We gotta get these concepts in so that they can be impactful in the near future. Now, there's also an emerging story coming out of the Idaho Department of Environmental Quality, where they are doing something really amazing. So they administer all the grant funds that the state gets from the feds to build water and wastewater infrastructure. And within their letter of interest process, which is the beginning of how you get that money, they said, we'll give you extra points on your evaluation if you include cyber-informed engineering. They recently received 80 letters of interest that explicitly included CIE. And that was about half of the letters submitted. Some of those projects, CIE really isn't gonna work, right? Holding pond, probably not applicable. But if you think about, we could have 80 utilities doing CIE in the next 5 to 10 years, that's really an amazing thing. And shout out to IDEQ. All right, so the CIE implementation guide, if you're looking for a place to start, this is the core document. There's really 2 things I want to highlight first here. First, there's a case study in the back about a water wastewater utility who has adopted CIE and they're going out and they're doing it. The second is that when you look at this document, you're not going to get a bunch of, you need to go do this, you need to go do that. You're going to get a bunch of questions. And you're going to get 1,152 questions. Now, you've seen 12 of these already, so you only have 1,140 left to go. Now, you might be thinking, that's really a lot. But let's think about this. There are 12 principles. There are 7 systems engineering lifecycle stages. So when you divide that math out, What you wind up with is about 14 questions per principal per life cycle stage, which is a wonderful starting point for you wherever you are in your infrastructure. Now, there's wonderful CIE resources out there. There's too many to list. The font size is really small on this slide. I'm sorry about that. But the point is, there's lots out there. West Yost is going to be making a really significant contribution to this in October of 2025, when a CIE for the water sector book should be published and released by the American Water Works Association. We're very excited for that. And I just want to say thank you to Ginger Wright and her team at the lab and the community of CIE practitioners, because we're out there, we're really doing some wonderful things. I hope you can all sign up and be part of this. Thank you. All right, and the organizer did say if you want to ask a question, please go to the mic like this gentleman did. Thank you.
Just one question.
Yeah.
There's an awful lot of really small water utilities.
There are.
And they don't even know where to start. They don't even have they've never heard these terms.
Yep.
And they think they can operate mostly manually. What do you say to them? How do you get them started in this? How do you even broach the subject? Because most of their systems are designed by outsiders, by contractors. How do you even get that culture going from the outside?
Yeah, so whenever they say we can do this manually, my response is prove it. And don't do it for me, do it for yourself. Unfortunately, there's been a trend of adopting processes in our sector that are much more automation dependent, which is actually making it so that these utilities cannot operate manually. And what I'm really trying to do is get them to understand that they can't do that and create a plan B. I think in time, a lot of those small utilities will be best served by checklists and some very simple design principles that the engineering companies have to actually implement. Hopefully that helps. Thank you. All right, thanks everybody.